Imagine, like, a supply chain manager spots a massive warehouse just full of obsolete, dusty boxes.
Yeah, stuff that just hasn't moved in literally years.
Right. So they decide to be a hero, clean house, throw it all out, and, save the company millions in storage fees and taxes.
Which sounds completely logical on paper.
Exactly. But the second they toss those boxes, they accidentally trigger a technical default with their bank and push the entire, multi-billion-dollar company to the absolute brink of bankruptcy.
It's wild, just from throwing away useless boxes.
It really is. So welcome to the Deep Dive. You're here because you want to know how the machine actually works. And today, our mission is to understand the hidden mechanics, the staggering costs, and frankly, the invisible strategic power of inventory.
Because inventory is so much more than just, counting products sitting on a shelf.
Totally. We're looking at the exact frameworks supply chain masters use to balance supply, demand, and cash flow. Okay, let's unpack this, starting with the fact that inventory is this massive contradiction, right?
It really is. It is the literal lifeblood of global commerce. But to understand how that manager could accidentally bankrupt a company, we have to grasp that fundamental contradiction. Inventory is simultaneously an asset and a massive liability.
Which is such a weird way to think about stuff you're trying to sell.
Yeah, well, the frameworks we're exploring today break this down into 5 core types to kind of manage that contradiction. Most people, they really only think of 3.
Right, the basics. Raw materials, which are the unshaped inputs, work in process, or WIP, which is the stuff actively sitting on the assembly line. And then finished goods, the final product.
Exactly. Ready for the consumer. But the 4th type is in-transit inventory, the whole distribution side.
Which is wild to think about because that means a huge chunk of the world's wealth is just zooming down the highway or floating on container ships at any given moment.
Yeah, it's just moving inventory, constantly in flux.
Okay, so what's the 5th one? Because you mentioned 5 types.
The 5th type is where the contradiction gets really interesting. It's called MRO. That stands for maintenance, repair, and operating supplies.
Like what? What does that actually mean?
We're talking about spare gears for the conveyor belt, industrial lubricants, even the janitorial supplies and safety gloves for the workers.
Wait, none of which actually go into the final product you're selling to the customer.
None of it. But think about it. If you run out of safety gloves, the union stops the assembly line.
Oh, wow. I didn't even think of that.
Yeah, a $5 box of gloves can literally halt $5 million a day in production. And what's fascinating here is how finance and accounting treat MRO compared to the other types of inventory.
How so? Is it taxed differently?
It's about the balance sheet.
So,
the raw materials and finished goods, they sit on the balance sheet as traditional assets. You hold them, they hold value. But MRO inventory is expensed immediately upon purchase.
wait, really? Even if you haven't used it yet?
Exactly. It hits the income statement as a cost right away, even if it just sits in a supply closet for 6 months.
So operations wants tons of MRO on hand to make sure the machines never stop, right? But finance absolutely hates it because it looks like pure spending with no asset value to offset it.
Precisely. It creates this immediate tug of war between departments.
That makes total sense. But looking at the broader picture, the raw materials, the finished goods, why hold massive piles of it at all? Why not just make a product the exact second someone orders it?
Because reality is bumpy. It's unpredictable. Companies hold inventory for 4 specific functions to deal with that.
Okay, lay them out for me.
First is cycle stock. That's your everyday replenishment. You sell 10 a day, you bring in 10 a day, normal stuff. Second is anticipation inventory.
Like building up stock ahead of the holidays.
Exactly. A known event, a holiday rush, or a major marketing promotion. Third is safety stock, which is your buffer against the unknown. Say a supplier's truck breaks down, or a viral video suddenly quadruples your sales overnight.
Right, the stuff you can't predict. And the 4th.
Finally, hedge inventory.
Hedge inventory. That sounds like a financial bet.
Because that's exactly what it is. You're speculating against a future risk. If you hear whispers of a looming dock worker strike, or you forecast a massive spike in the cost of raw aluminum.
You buy aggressively right now to lock in the supply and the price.
You got it. It's pure risk management.
I usually picture inventory as this giant shock absorber on a car.
Oh, yeah.
You've got the bumpy road of supply on one side, strikes, weather, delays, and then the totally unpredictable potholes of customer demand on the other.
That's a great analogy, actually.
Right. And inventory just sits right in the middle, decoupling those two volatile forces so the customers, feel a perfectly smooth ride. They click buy, it shows up 2 days later, and they never feel the bumps.
They're completely insulated from the chaos.
But that brings up a huge question for me. If inventory is such an amazing shock absorber, why don't companies just put massive, oversized shock absorbers on everything? Like, just hold tons of stock everywhere all the time.
Because oversized shock absorbers completely numb you to the feeling of the road.
What do you mean?
Well, if you have endless safety stock, you mask the actual flaws in your operation. You never realize your primary supplier is chronically late or your manufacturing equipment is wildly inefficient.
Because you just keep pulling from the massive buffer whenever there's a problem.
Exactly. Your quality control could be slipping, but nobody notices because the buffer hides the pain.
And eventually, paying for that massive buffer has to catch up to you, right? Which brings us back to that hero manager from the intro who accidentally caused a bankruptcy. Maintaining those giant shock absorbers has to cost an astronomical amount of cash.
Oh, it does. It's staggering. Across an entire supply chain, 40 to 50% of a company's invested working capital can just be tied up in inventory.
Half of their available cash is just sitting there in boxes.
Half. And holding it is far from free. We look at this through the lens of carrying costs versus ordering costs.
Okay, let's start with carrying costs. That's just warehouse rent, right?
It's so much more than rent. It's the property taxes, the insurance premiums, the cost of security to prevent theft, and the massive risk of obsolescence.
Oh, right. Like if you're selling tech gadgets, a 6-month-old inventory might as well be garbage.
Exactly. Annually, carrying costs can bleed 15 to 40% of the inventory's value.
Wait, 15 to 40%. So if I have $10 million of inventory sitting in a warehouse, it's quietly costing me up to $4 million every single year just to let it sit there.
Just to let it gather dust, yes.
That is insane. Okay, so on the flip side, what are ordering costs?
Ordering costs are the friction of actually getting the inventory. It's the administrative labor of generating purchase orders, the setup time required to reconfigure a machine for a new batch.
The labor of unloading the trucks, inspecting the goods.
Right. So if you place 1,000 small orders, your ordering costs skyrocket. But if you place one massive order, your carrying costs skyrocket.
So what does this all mean? Like if I'm looking at my own business, it sounds like ruthlessly reducing my cost of goods sold, leaning out this massive inventory burden is going to boost my profit way faster than just trying to sell more product.
That is exactly the logic that gets managers into trouble.
Because if I sell more, my variable costs go up too. But if I cut dead inventory, I free up pure cash. That sounds exactly like what our hero manager was trying to do.
Yes. The manager saw dead stock carrying costs literally bleeding the company dry and decided to write off 60 million euros of obsolete inventory to lean out the warehouse.
Which feels like the right move.
Operationally, yes. But this is where the operational world collides violently with the financial world. When you write off an asset, it hits your income statement as a loss.
Okay. And that loss reduces your company's retained earnings. Let me make sure I have this straight. Retained earnings are basically the cumulative profits a company has saved up over time, which sit on the balance sheet as part of the owner's equity.
Correct.
So by writing off the inventory, the manager shrank the company's equity.
Exactly. And this company had a very strict loan covenant with their bank. The bank required them to maintain a 2-to-1 ratio of equity to liabilities.
Oh no, I see where this is going.
Yep. The moment that 60 million euro write-off hit, the equity shrank, and the ratio dropped below the 2-to-1 threshold.
They broke the contract.
Instantly. The company fell into technical default. The bank had the legal right to demand full repayment of the massive loan immediately, pushing the company toward bankruptcy.
Just because a manager threw away dusty boxes.
Because the manager was looking purely at warehouse efficiency and completely missed the financial tripwire.
That is a terrifying cautionary tale. But let me challenge the operational side of this. If holding too much stock is a financial death trap, but we just established that writing it off blindly can be equally dangerous, how do you decide what stays and what goes?
That's the million-dollar question.
Right. Doesn't relentlessly minimizing your buffer just lead to terrible customer service?
Yeah.
Like when a clothing store never has your size in stock, or a critical car part is back-ordered for 6 months.
If we connect this to the bigger picture, you are hitting on the fundamental tightrope walk of supply chain management. If you cut inventory too deep, you incur the massive hidden costs of stockouts.
Like lost sales.
Worse than that, the cost of a stockout isn't just the $50 sale you lost today. It's the lifetime value of the customer you lost forever because they went to your competitor and never came back.
So you have to be surgical. You can't afford to hold massive shock absorbers for everything, but you absolutely cannot afford to run out of the things that matter most.
Precisely. You have to ruthlessly prioritize your physical items.
How do companies actually do that?
The gold standard for that surgical prioritization is ADC classification. It's a direct application of the Pareto principle, the 80-20 rule, applied to aggregate inventory management.
Okay, so how does the math work?
You evaluate every item based on its annual dollar volume. That's the cost of the item multiplied by how many you sell in a single year.
So a super cheap item that sells millions of units could be just as critical as a luxury item that only sells 10.
Exactly. Volume matters as much as unit price. Once you calculate that, you split the inventory into 3 tiers. Items are your VIPs.
The VIPs.
Yeah.
Got it.
They make up only about 20% of your physical items, but they account for roughly 80% of your total inventory value.
Okay. And the B items?
B items are the middle tier, about 30% of the items representing 15% of the value. And then C items are the filler.
The bottom of the barrel.
Right. They make up 50% of your physical catalog, but account for a tiny 5% of your total financial value.
This makes complete intuitive sense if you look at, like, a kitchen pantry. You care deeply if you run out of coffee. Coffee is an A item.
You definitely notice when the coffee is gone.
Right. You track it. You know exactly how many days you have left, and you buy it exactly when needed. But nutmeg is a C item.
You buy a little jar once a decade.
Exactly. You shove it to the back of the shelf and completely forget about it. You don't apply coffee level management to nutmeg.
You apply intense rigor to the A items. They get stored in the most secure cages in the warehouse to prevent theft. They are forecasted with incredibly sophisticated algorithms.
So you're micromanaging them.
Highly micromanaged. And they are often managed using lot-for-lot replenishment, meaning you only order the exact quantity needed for a specific production run. You keep the holding costs as close to zero as humanly possible because these items are so expensive.
But let me throw a wrench into the nutmeg analogy for a second.
Go for it.
What if a C item is a tiny 2-cent specialized bolt? Based on the formula, it's worth almost nothing annually. But without that specific bolt, a multi-million-dollar robotics assembly line completely stops. Isn't the true value of that bolt completely detached from its 2-cent cost?
That is a brilliant distinction, and it perfectly highlights why aggregate mathematical models still require human intelligence.
So the formula fails there.
It does. For highly critical C items like your 2-cent bolt, you abandon the lean lot-for-lot approach entirely because the carrying cost of 1,000 2-cent bolts is statistically zero, but the cost of a stockout is a total catastrophe.
Right, the factory shuts down.
So you use a strategy called safety lead time. You order them weeks in advance, and you order them in massive batches. You intentionally overstock the C items specifically to protect the production of the A items.
Okay, so you've mapped out your entire catalog. You know exactly what is an A item, what is a B item, and what is a critical C item. But once you've classified everything, the next massive dilemma is geography, isn't it?
Where in the physical world do you put these items? Yes.
Right, to balance those carrying and ordering costs we talked about earlier.
This brings us to the concept of supply chain echelons. An echelon is simply a layer or a node in the network. The manufacturer's factory is an echelon. The regional distribution center is an echelon.
The local wholesaler, the retail storefront, each time the box changes hands, it enters a new echelon.
Exactly. And every time you add an echelon, you're deciding who actually controls the inventory,
No.
which opens up the massive debate between centralized and decentralized planning.
Why is that debate so important?
It's one of the most critical structural decisions a company makes. In decentralized planning, every single node, say, every retail store, acts completely independently. The local store manager looks at their shelves and orders what they think they need from the wholesaler.
Which sounds agile, but I'm guessing there's a catch.
The danger here is a cascading phenomenon known as the bullwhip effect.
Wait, I've heard of this. It's where a tiny flick of the wrist at the retail level creates a massive crack of the whip down at the factory level. How does that actually happen in real life?
Okay, imagine a local hardware store has a sudden, random weekend where 5 people buy a specific snow shovel. It's a tiny blip.
Sure, maybe it's note a little.
Right. But the decentralized store manager thinks, oh, this is a trend, and orders 50 extra shovels just to be safe.
Okay.
Then the regional wholesaler sees an order for 50 shovels from one store, assumes a massive winter storm is coming, and orders 500 from the distribution center.
Oh, man. And the distribution center panics and orders 5,000 from the factory?
Exactly. The factory authorizes overtime, buys extra raw materials, and cranks out 5,000 shovels. But the initial demand was just 5 people.
So 2 weeks later, the whole system is just choking on thousands of shovels nobody actually wants.
That is the bullwhip effect in a nutshell. Decentralized planning relies on distorted signals. Centralized planning counters this by taking control away from the individual stores.
So headquarters makes the call.
Right. Inventory is pushed down through the echelons from the top based on aggregated system-wide data, completely preventing that panic ordering cascade.
But hold on, every time you utilize an echelon like passing goods through a regional distribution center or a break bulk warehouse, you add rent. You add labor to unload the truck. You add time.
Yes, you do.
Wouldn't the ultimate, leanest, most mathematically perfect supply chain just strip all those echelons out and ship everything directly from the factory straight to the customer's front door?
It feels like it should be cheaper, but the transportation math dictates otherwise entirely. The key concepts here are consolidation and break bulking.
Walk me through that math.
Let's say a major retailer has 100 different factories scattered across Asia and 100 retail stores across North America. If every factory ships individual direct parcels to every single store, you are paying for 10,000 highly inefficient, incredibly expensive trans-Pacific shipments.
A logistical and financial nightmare. You're paying premium parcel rates for every single box.
Precisely. So you add an echelon to save money. All 100 factories ship full, tightly packed truckloads to a single consolidation warehouse in Asia.
Okay, so they group it all together.
Right. That warehouse mixes the products and loads massive, highly efficient sea containers. Those containers cross the ocean cheaply and hit a single break bulk warehouse in North America.
And then they split it back up.
That warehouse unloads the containers, mixes the goods, and sends full truckloads to the individual stores. Yes, you paid for 2 extra warehouses and the labor to run them, but the massive savings in bulk freight costs deeply outweigh the added rent.
Here's where it gets really interesting. Because once that inventory is physically positioned in the perfect echelon, the daily operational battle kicks in. The manager's just staring at a shelf. When exactly do they trigger an order for more, and what is the exact right amount to buy?
Now we enter the math of restocking. And the foundational framework for this is the economic order quantity, or EOQ. It goes right back to the 2 financial burdens we discussed earlier, carrying costs and ordering costs.
Right. If I order a huge amount of stock, my carrying costs, the rent, the insurance go way up. But if I place 100 tiny orders, my administrative ordering costs and shipping fees go way up.
Exactly. If you graph carrying costs, it's a line sloping up. If you graph ordering costs, it's a line sloping down. When you combine them to find the total cost, it forms a perfect U-shape.
And EOQ is at the bottom of that U.
The economic order quantity is the exact mathematical sweet spot at the absolute bottom of that U-curve. It is the precise quantity where the cost of holding the inventory perfectly balances the cost of acquiring it.
I always think of EOQ like my strategy for buying groceries. If I go to the grocery store every single day and buy just enough for dinner, my holding cost is basically zero. My fridge is empty. Nothing ever spoils.
But your ordering cost is terrible.
Astronomical. The gas, the wear and tear on the car, the hour I lose standing in line every day. But if I try to optimize my time and only go to the store once a year, my gas cost drops to zero, but I'd have to buy 10 refrigerators to hold all the food.
That is a brilliant way to visualize the trade-off.
So EOQ is the math that tells me go into the store exactly once a week, perfectly balances the gas money with my available fridge space.
Yes. But EOQ only tells you how much to buy. You still need a system to tell you when to buy it. The standard models are the order point system and the periodic review system.
And they differ.
In an order point system, you set a trigger. The moment your inventory drops to a specific minimum level, you order your fixed EOQ amount. If you look at a graph of this over time, it looks like the teeth of a saw.
The classic sawtooth inventory graph. You wait for the trigger, then replenish. The stock steadily drops, hits the trigger point, and then shoots straight vertically back up when the new batch arrives.
Exactly. But a periodic review system ignores the trigger. Instead, you check the stock on a rigid schedule, say, every Friday at 5 p.m.
So time is the trigger, not the quantity.
Right. You look at what's currently on the shelf, and you order a variable amount to bring the inventory back up to a predetermined maximum target. Supermarkets love this because it allows them to review 100 different items on Friday and consolidate all the wildly different order amounts onto a single delivery truck.
That makes sense for logistics.
Right.
But let me push back on this beautiful U-shaped EOQ math.
Okay, let's hear it.
The formula calculates the perfect order quantity, assuming that customer demand is flawlessly constant and that the delivery truck never hits a snowstorm or breaks down. But we just established that the real world is bumpy. Isn't EOQ basically a mathematical fairy tale if it ignores volatility?
It is a theoretical baseline, which is exactly why it can never be used in isolation. To protect the EOQ model from the chaos of reality, managers wrap it in those safety buffers we talked about.
Oh, like the safety stock.
Right. If customer demand is volatile, you hold safety stock extra physical units just in case. If your supplier's delivery times are volatile, you use safety lead time.
Which means ordering early.
Ordering the EOQ quantity a week earlier than the math dictates just in case the truck breaks down.
Yeah.
You use the math to optimize the core flow and the buffers to survive the real world.
But there is an even bigger reality check lurking underneath all of this. Every single mathematical model, EOQ, order points, safety stock algorithms, they all completely rely on the integrity of a computer database.
Yes, they do.
And all of that math will spectacularly fail if the computer thinks you have 100 units on the shelf, but you actually have 0 because someone stole them, or, a forklift ran over the pallet, or a tired worker just typed in the wrong barcode.
And that brings us to the final and arguably most vital piece of the puzzle: inventory accuracy and traceability. If your digital records don't match physical reality, your supply chain is flying blind into a mountain.
How did companies fix this before modern software?
Historically, companies tried to fix this through something called periodic counting. Once a year, usually over a long, grueling weekend, they would freeze all shipments, shut down the entire warehouse, and send armies of temporary workers with clipboards to count every single box.
That sounds incredibly painful, expensive, and frankly, prone to even more errors because temps don't know a specialized resistor from a capacitor.
It was a complete nightmare, and when they inevitably found massive discrepancies between the clipboard and the database, they just shrugged, wrote off the missing millions, and started over.
Wow. So what's the solution today?
Today, the elegant standard is cycle counting. Instead of shutting down the business, you count a small, rotating subset of items every single day while operations continue normally. You might count aisle 4 on Tuesday and aisle 5 on Wednesday.
I imagine we bring our ABC classification back into play here.
Exactly. You don't count everything equally. Your highly critical, expensive A items might get cycle counted every 20 days.
To keep a really close eye on them.
Right. Your middle-tier B items every quarter. And your low-value C items maybe only once every 6 months. It ensures the database remains highly accurate without grinding the business to a halt.
But wait, why even bother counting the C items at all? If that tiny 2-cent bolt is worth almost nothing, why pay a worker $20 an hour to walk over and count them? Why not just wait until the plastic bin is visibly empty and then hit reorder?
Because of the financial auditors. Even if the item is cheap, inventory is a legally reported financial asset.
Ah, right. It all comes back to the balance sheet.
Discrepancies in your C items still corrupt the balance sheet. If your database claims you own 100,000 bolts and you actually have 0, your asset ledger is basically fraudulent.
Oh.
Yeah, if it's wrong enough across enough items, it triggers severe auditing disasters and SEC violations. It all comes back to the fact that inventory is money.
And eventually, that money turns into a pure liability.
Mm-hmm.
Products die, tech trends end, food expires. Which brings us to the end of life of an item. What happens when inventory is officially dead?
This raises an important question. How do you responsibly dispose of dead inventory without ruining your profit margins or creating an environmental disaster?
Right, because it's just sitting there costing carrying fees.
When an item becomes obsolete, it is occupying highly expensive warehouse space while offering 0 financial return. The frameworks lay out specific dispositions.
What are the options?
You can attempt to return it up the chain to the manufacturer. You can liquidate it to a secondary market like a deep discount retailer. You can donate it to a charity for a corporate tax write-off.
And if none of those work?
Or, as a last resort, you recycle or destroy it. But the golden rule is doing nothing and keeping dead inventory on the shelf is almost always the most expensive option.
Okay, we have covered some serious ground today. To the listener, think about the journey we just took. We started by looking at inventory as just a simple, dusty box sitting on a warehouse shelf.
A box that most people ignore.
Right, but now you can see it for what it truly is. It's a high-wire financial tightrope that dictates a company's cash flow and survival. It's an intricate mathematical optimization puzzle balancing echelons, EOQs, and cycle counts. It is quite literally the heartbeat of global commerce.
When you truly understand inventory, you stop seeing supply chains as just a collection of trucks and buildings. You start seeing them as massive flowing rivers of capital, strategy, and risk.
Now, before we sign off, I want to leave you with one final provocative thought to mull over. We spent this entire deep dive exploring the necessity of holding inventory to decouple supply from demand, building those giant shock absorbers.
Right, the essential buffers.
But what happens if 3D printing and hyper-local micromanufacturing continue to advance? What happens to these massive, complex, trans-Pacific supply chains when the lead time to create a custom product drops to practically zero?
That changes everything.
Exactly. Will the entire concept of holding an item inventory completely vanish from the corporate balance sheet? Are the supply chains of tomorrow going to be networks that just beam pure data to a printer in your house instead of moving physical boxes across the ocean? Keep looking behind the curtain and keep questioning the invisible systems around you. We'll catch you next time.